Object serialization. Serialization is the process of writing the state of an object to a byte stream. And this is useful when you want to save the state of your object so that later we can use it. Or if you want to save the state of your program to a persistent storage area, let it be a file so that at later time you can restore these objects by using the process of deserialization. That is storing the state of an object where object is a runtime entity. So storing the state of an object to a byte stream is called serialization. And this serialization is also needed to implement a very important concept called remote method invocation RMI in Java. RMI is a process in which a Java object on one machine invokes a method of a Java object on a different machine. Here, an object will be supplied as an argument to that remote method. For supplying the object as an argument, the state of the object should be passed to that method, and here the state will be first converted to the byte stream and then will be passed to that particular remote method. The sending machine serializes the objects and transmits it, and the receiving machine deserializes it. Assume that an object to be serialized has references to other objects, which in turn have references to still more objects. This set of objects and relationships among them form a directed graph. There may also be circular references within this object graph. That is, object X may contain a reference to object Y, and object Y may contain a reference back to object X. Objects may also contain references to themselves. The object serialization and deserialization facilities have been designed to work correctly in these scenarios. If you attempt to serialize an object at the top of an object graph, all of the other referenced objects are recursively located and serialized. Similarly, during the process of deserialization, that is, deserialization is obtaining the object from the byte stream. Deserialization, all of these objects and their references are correctly restored. If you want to make an object as serializable, then you have to implement the serializable interface. Only an object that implements the serializable interface can be saved and restored by the serialization facilities. The serializable interface does not define any members inside it. It is used simply to indicate that a class may be serialized. And if a class is serializable, all of its subclasses are also serializable. And if you don't want a variable to be serialized inside the class, then that variable can be declared as transient. And static variables are also not saved by the serialization facilities. Externalizable. So Java facilitates facilities for serialization and deserialization have been designed so that much of the work to save and restore the state of an object occurs automatically. However, there may be situations where the programmer may need to have control over these processes. For example, sometimes it may be desirable to use compression or encryption techniques on the object streams. In such situations, externalizable interface is used. The externalizable interface defines two methods. The first is void read external, throws IO exception, class not found exception, and second is void write external, throws IO exception. In these methods, the in stream is the byte stream from which the object is to be read, and outstream is the byte stream to which the object is to be written. The object output interface extends the data output interface, and it supports object serialization. It defines the methods as shown below. Here we can see the write object method. We have a write object method, and this is called to serialize an object. All of the listed methods will throw an IO exception on error conditions. Object output stream. This class extends the output stream class and implements the object output interface. It is responsible for writing objects to a stream. A constructor of this class is object output stream. You have to pass the output stream object and it throws the IO exception. The argument outstream is the output stream to which serialized objects will be returned. The most commonly used method in this class are shown in the given table. They will throw an IO exception on error condition. Other methods supported are void close. It closes the invoking stream, and it further writing attempt will lead to an IO exception. After closing the stream, if you want to write something, it will generate an IO exception. Then we have other functions like flush, write boolean. It writes a boolean value to the invoking stream. Write byte. It writes a byte value to an invoking string. Similarly, we have write char. These are some of the methods supported. The object input interface. This object input is an interface which extends data input interface, and it defines the methods shown below. It also supports object serialization. Here we have a read object method. This is called to deserialize an object. All the listed methods will throw an IO exception on error condition. Some of the methods are int available. It returns the number of bytes that are now available in the input buffer. Void close. It closes the invoke stream. So after closing the stream, if you further try to read the stream, it will generate an IO exception. Then we have a read, int read. It will returns an integer representation of the next available byte of input, and -1 is returned when end of the file is encountered. We can see a serialization example where we have started by writing a class called my class that implements the serializable interface. And as a result, the object of this class can be serialized since we are implementing the serializable interface. And this class contains three variables that are of type string, int, and double. And these are the information that we want to save and restore. Next, we will be writing a class called serialization demo where we will be writing the main method. So the main method will be containing the code for object serialization, which will be properly enclosed inside the try catch block for handling any exceptions that can occur. So our aim is to create an object and then convert this object into an object stream, write into a file and store it for later use. And for writing into a file, I have used the file output stream class, which is linked to the file named serial. And then for converting into the stream, object output stream class has been used. And using the object of this particular class, we will be invoking the method write object, which writes the object to the invoking stream. And then flush and close method has been called so that any buffer, it flushes the buffer, and then close method will close the invoking string. This code describes the deserialization process of the object. So we have serialized the object and written inside the file called serial. So from the serial named file, text file, we will be reading the streams, converting it back to objects. From reading the file, we have used the class called file input stream, which will be associated with the file named serial. And then we have object input stream for invoking the read object associated with the class, so that it reads and returns an object from the invoking stream. And then the stream will be closed by using oas dot close.